Hello, Algebra 2 students. Today we are going to do 6.2 notes, apply properties of rational exponents. These should look really familiar because we looked at the same properties of exponents in section 5.1, but the exponents were positive and negative integers, not fractions. The same rules apply. So the properties are on the left side and the examples are on the right side. So if you look at the first property, when you have the same base, you add the exponents. So if you look at the example, 12 to the 1/8 times 12 to the 5/6, you don't multiply the 12 times 12. You leave the base alone, but you add the exponent. So 1/8 and 5/6. So you want to multiply top and bottom by 3 here to get a common denominator of 24. And there you multiply by 4. So we have 12 to the 3/24 times 12 to the 20/24, which is 12 to the 23/24. Okay. Example 2, or the second example, when you have a base in the parentheses and you have exponent on the outside, what you do is you distribute the exponent to the other exponent and you multiply them. So that's a to the m times n. So here you would multiply the 3/5 times the 5/1. So 3 to the 3/5 times 5/1. So that's 3 to the 15/5, which is 3 to the 3rd, which is 3 times 3 times 3. Okay, next one. When you have different bases inside the parentheses, so if you look at on the left side, you have a and b are both bases. The exponent that's outside still gets distributed to each base. And so that's a to the m times b to the m. So do that. It never is shameful to draw arrows. You cannot draw enough arrows in algebra. So 8 to the 4th times 17 to the 4th. And you just leave it like that. I would not go and multiply 8 times 8 times 8 times 8, whatever it is, times 17 to the 4th. I just wouldn't do it. Okay, for the negative exponents, remember, this is over 1. And so you just flip the numerator and denominator and make the exponent positive when you do move it. So this is over 1. So it'd be 1 over 5 to the 3rd, which is the same thing as 1 over 125. Right, move that. Okay, now the last two properties deal with quotients. So when you're dividing and you have the same base, you subtract the bottom exponent from the top exponent. Always bottom from the top. So here we have 10 to the, okay, so this is 10 to the 1st. So it'd be 10 to the 1 minus 2/5. So we have to have a common denominator. So that's going to be 5. So 5/5 minus 2/5, which is 10 to the 3/5. Okay, and our last one of the properties of exponents. So this one's kind of hard because it has several properties. Well, the base, you have two different bases. You have a base of 56 and a base of 7, but you also have two exponents. So you're going to, first thing you're going to do is distribute. Exponents gets distributed to another exponent if you see it. So that's 56, and you multiply 1/4 times 12. So that would be 12/4. And the bottom would be 7 to the 12/4. So that's 56 to the 3rd power. 12 divided by 4 is 3. And 7 to the 3rd. Now, do we cancel out 3's or anything? No, but you could do this because they're the exact same exponent. You can do this. It's the same thing. And then you can simplify 56 divided by 7 is 8 to the 3rd power, which is 8 times 8 times 8, which is 512. All right, now for the properties of radicals. We are going to look at the product property of radicals and then the quotient property. So the first one is product. So notice you have a root on the outside, you have bases on the inside, you can separate them. into the individual bases because they have the same root. Same thing for the quotient property on the right. So if you look at this index, if it's going to be the same for each number, each base. So you could just separate it. So it'd be nth root of a divided by the n, or I'm sorry, radical a, sorry, whatever n is. That's how you would write it. Okay. And b just can't equal 0 because you can't divide anything by 0. All right, so we'll look at some easier ones and then we'll work our way into some more difficult ones. So the first example, example A on the bottom of this page, the cube root of 125 is 5, and the cube root of 8 is 2. And then you multiply those two, so that's 5 times 2 is 10. Now, if this is a little bit difficult for you, here's how I'm going to teach some of these when they get more difficult. So you can write the cube root of 125 as prime numbers. Oops, I don't know why I did that. So 5 times 5 times 5. And the cube root of 8, what number multiplied by itself 3 times gives you 8? Like that. And then, because this number means 3, you're going to have 3 of a kind. That's the same number. So here you have 3 of a kind, but you just want one of them outside. Same with this. And so your answer is 10. It's a lot of work, especially if you have those memorized. If you have them memorized, it's not that big of a deal. So for this one, the 5 is your index, so you can combine that under one radical like this. And then you could do 96 divided by 3, which is 32. And then the fifth root of 32, remember, what number multiplied by itself 5 times gives you 32? And the answer is 2. So you have 5 of a kind, and you just want to pull out one of them. All right, going to the back page, write the expression in simplest form. So now we are working our way into harder ones. First page, A and B on the bottom was not hard. Now we're going to get to the ones where they don't work out nicely, so to speak. So here's where we're going to have to use a little bit of our skills. And this is a little harder, but just kind of keep in mind, just follow along, see what you can do. So the cube root of 104. If you try to use a calculator, it's going to give you some ugly decimal, and we just don't do decimals. You cannot. When I'm asking you to write something in simplest form, you're not allowed to use decimals. So the way you can think of it is, think of the numbers I had you memorize from 6.1. I said, oh, for cube roots, you should memorize all the way up to cube root of 216, because the answer was 6. So the cube root of 104, you know, what you want to do is try and break 104 into two numbers that multiply together, or one of them is a perfect cube. And I know 8 is a really good cube root. So 8 times 13 equals 104. And then you can separate that as cube root of 8 times the cube root of 13. You can do that. Those are two different numbers, but they have the same index. Cube root of 8 is 2. This one, 13, is not a perfect number that you can take the cube root of, so you would just leave it alone. And you leave anything you can't take the cube root of or square root of, it stays inside. So this is your final answer. You can also approach this problem. Once you do this step right here, you can write it out like this. And you want to look for a 3 of a kind, because that's a 3. And so you just take out one of those, and then anything else stays inside. So you can just look at this problem two different ways. Which way is going to work better for you? That's totally your call. Okay, so for this next one, fourth root, numbers can be multiplied. These two numbers can be multiplied if those are identical, and they are. So 10 times 3 is 30. Okay, and I'm going to break down 30 as, you could do, well, you don't want to do 10 times 3, but you can do some other numbers like 2 times 3 times 5. Use prime numbers. That's what you want to do. That's your whole goal. 10 was not prime. So 10 had to break down. So I broke down 10 as 2 times 5 and then the 3. But notice there are no, there's nothing 3 of a kind. So this never simplified. And that's your answer. Okay. All right. Now for some ones where we involve variables. So for this one, the fourth root of 625 is one of those that you can use a chart for, or if you had memorized it. So I'm going to do this 2 different ways again. So the fourth root of 625 times the fourth root of z to the 12th. Okay, so I'm going to show you. I know, because I've been doing math forever, that 5 times 5 times 5 times 5 is exactly 625. So what number multiplied by itself 4 times gives you 625? It's 5. This one, so whenever you have a variable, all you do is you take this exponent right here and divide it by the index. So 12 divided by 4 is 3. So it'd be z to the third. Now, if you rather see it all written out, this is what I would suggest that you do. So the right side is the one that takes longer, but it's easier to understand. So if I were to say, hey, break down 625 into a product of prime numbers, it'd be 5 times 5 times 5 times 5. And that gives you, and then let's go ahead and do the z's. I'm writing too big here. So I would write z to the third times z to the third times z to the third times z to the third. And you have 4 of a kind. Same here, 4 of a kind. So you take out 1, take out only one of these. How did I know to do z to the third? Because again, you just take that 12 and you divide it evenly 4 ways. And so it'd be z cubed. And that's what you do on that one. Okay, for the next one. So I'm going to write it in radical notation. So bottom number, remember, from section 6.1 is your index. Bases go inside. So 32, m to the 5th, n to the 30th. There we go. And then you can split it up. Well, everyone should know the 5th root of 32 is 2. 5 divided by 5 is 1, so m to the 1st, and 30 divided by 5 is 6. So honestly, this is probably the easiest way to do this particular problem, but you could have done it like this as well. You just have 5 of a kind. And I just took out 1 of each kind. And our last one for this particular one. So this one's not too bad looking. Let's go ahead and take a look at it. So we can split that up into 6th root of r to the 6th divided by 6th root s to the 18th. Okay. So 6 divided by 6 is 1. So r. And then 18 divided by 6 is 3. That's how you do that one. I feel like for that one, I shouldn't even show you but you have 6 of these r's. You only want 1 of them. You have s to the 3rd multiplied by itself 6 times and gives you s to the 18. All right. Write the expression in simplest form. No radicals are allowed in the denominator. We know that from chapter 5. So write the expression in simplest form. Let's look at the first one. So these are getting to like a little bit harder. So here's how I suggest doing this. Break them down separately. So you have cube root of 6, cube root of x to the 4th. Notice I write 4 x's because it's x to the 4th. Cube root of y to the 9th. That divides nice evenly because 9 divided by 3. 4 divided by 3 is not nice. And that's why we had the right amount. But y to the 9. So this 9 divided by 3 is 3. So you have y cubed times y cubed times y cubed. And then z to the 14th, again, that doesn't divide nicely. So here's what I would do for that one. Think of, well, 14 divided by 3 is going to be at least 4. So you can do this. You can still divide it, but the remainder will be the loner. So z to the 4th times z to the 4th times z to the 4th times z. So you can still divide it. You're just going to have a remainder. And that's what this was. You had an extra remainder right here. So your last x was a remainder. And so now cube root of 6, you can't take the cube root of 6. So it's going to have to remain inside. So everything we can't take the cube root of, or we can't find a 3 of a kind for. Here we have a 3 of a kind. So we want just one of them. So it goes out. The other x stays because there's no matching 3 of a kind. Here you have all 3 that are the same. So it goes out here. And finally, these 3 are the same. And then make sure you put this index right in that little crease of your radical. And then we should have a z here. So basically the 2 remainders went inside along with the 6. Okay, and our last one. So we have 7th root p to the 8th over 7th root p to the 5th. Okay, so there's a couple of different ways to do this. Let's see what might be the easiest. You can multiply, well, first of all, you want to multiply top and bottom. You can't have a radical in the denominator. So the best way to do this is, I'm trying to figure out the easiest way to do this and not be complicated for you guys. So, okay. I would most likely do this. Okay, so I multiply top and bottom by the 7th root of q to the, oh wait, this is, first of all, if I write the problem correctly, that would help. So, okay. So this was q to the 5th. So I multiply top and bottom by q to the 2nd. Okay, and then that gives me the 7th root of p to the 8th times q to the 2nd over the 7th root of q to the 7th. So I hope you see why I did that, why I chose q to the 2nd, because you want the numbers to divide evenly. So you wanted to somehow get q to the 7th. And the only way to get q to the 7th is to have this be a 5 and this be a 2. So that gets rid of the radical in the denominator, and that's good. So we get at least that gone. So the bottom is nice because 7 divided by 7 is 1. So it's q to the 1st. The top, we can break it down like this. Okay. I have 8 of these and 2 of the q's. And we can only pull out, remember, we want 7 of a kind. So the 7 of a kind is these. And you just want to take out one of them. So the one that you take out goes outside. Anything you can't take out goes inside. And you can't cancel the q's because one of the q's is outside. So that's your answer. Kind of hard. Will you have it on your test? Most likely not. Okay, and our last 3 examples are not scary looking, but you treat adding and subtracting with radicals the same way as you would adding and subtracting with variables. So if you only deal with the numbers in front. So if these are alike, which they are, then all you do is you take 18 minus 11. So that'd be 7. But you leave the radical stuff alone. You don't combine them. That's all you do. Okay. So look basically to see if they're alike. If they're alike, you're in really good shape. Okay. So this, oh wow, I did not mean to do that. Okay. There we go. Okay, so this is alike. Therefore, stop. So that would be 15 plus 8. So, whoa. Get out of there. Huh. There you go. Okay. There. Finally. All right. So 15 plus 8 is 23. And leave all that other junk alone. Highlighters probably work well for this type of problems. And then lastly, ooh, look, on the last one, you can't because the things are not alike. You need to make them be alike. So this one is a little harder, but we're going to do it anyway. We're going to tackle it. So we have 10 to the, this one's a little hard. So we have 10 times the 4th root of 5s to the 7th. It's not too bad though. So 5, you can't break it down anymore because that's a prime number. But s to the 7th, you can write it as s, s, s. I don't know why I picked 5. That looks like an s. So 3, 4, 5, 6, 7. And we want that 4 of a kind. So you can circle any 4s. So here's 4. And then the other one is minus 5 times the 4th root of 80. So 80 I can break down as 2 times 2 times 2 times 2. That's 16 times 5. Those are a product of prime numbers. So you just have to think prime numbers. And then s to the 3rd as s times s times s. And again, you want 4 of a kind. Okay, so now we can simplify that even further. So anything that's 4 of a kind goes outside and joins the 10. But then and then anything that you can't take with you outside stays inside. So the 5 stays, and then s to the 3rd stays. Minus, for the second one, the 2 joins the 5, so 5 times 2. And what stays inside is 5s to the 3rd. Now notice they're alike. So this now is alike with that, which is good. That's what we want. So there we go. So we have 10s minus 10. You can't combine that or call it 0, but you can subtract those two. Well, I mean, you can't really. That's what you put out there. Times 4th root of 5s to the 3rd. That one was really hard. Now this one is one that I would definitely not give you on a test, but these are your notes for today. Have a great day, Algebra 2 students.